Hello, I'm John Furrier with theCUBE. We are here at our New York Stock Exchange studio. Of course, we have our Palo Alto, California, here in New York at the NYSE, covering both coasts, East and West, tech and Wall Street money. We got a guest coming all the way from Canada, Greg Twinney, CEO of General Fusion, a company that is doing really good work to solve one of the biggest concerns we're seeing in our society and around the world. That's energy. Greg, thanks for coming on remotely. Appreciate it.
John, pleasure to be here. Thanks for having me.
So, obviously for the past decade or so, we saw the rise of mining on Bitcoin, crypto. We see the AI challenge right now, the arms race. Jensen Huang, the CEO of NVIDIA, who leads the option board every day here at the Stock Exchange, has presented a stack in his conference in DC recently, a couple months ago, and it was like a stack, a hierarchy of needs. Energy was on the bottom. Okay, so energy obviously is a huge deal. You guys are on track to do a commercialization with Fusion. It is very difficult, and there's been a lot of people trying this. Tell us about what you're working on, status, progress, and what it's all about.
Great, yeah. So first of all, yeah, as you kicked off, I mean, the demand for energy that has been increasing and accelerating has only just exacerbated by AI, data centers, crypto, you name it. All of these things, electrification of everything, driving huge demand for electricity, for energy. And when you look across the globe at the existing technologies, there's going to be the ability to increase, of course. You can drill, you can put fission on the grid, but ultimately you're going to need a clean, virtually limitless base load, like on-demand energy source. And to accelerate the pace of all of these things that we hear in and around AI. And I listen to similar probably podcasts that you do and talks and attend different conferences, and energy is going to be the pace setter for the advancement of these technologies. And we're set up at General Fusion to be a leader in bringing fusion to market, and our current target, based on all of the work that we've done over the last 2 decades, is that we will have our first of a kind up and running by the mid-2030s, which isn't that far off.
Yeah, I mean, it's a code that not many people have cracked at all commercially. What's the hard problem? What is the pacing item? What's the blocker? What are some of the things that you're looking down the road at that you're working on?
Yeah. So the science of fusion, we see fusion every day when we look up at the sun and the stars. That's fusion happening right in front of us, and we depend on it. Creating those similar conditions inside of a machine on Earth on demand is what we and others are looking to do. The science has been proven at all sorts of different scales in national labs and academia. And really what the industry needs to do, and where we are a leader in, is taking that science, the demonstration of fusion, and moving it from science project ultimately to commercial power plants that can be deployed globally and satiate that huge energy challenge. And so from the beginning at General Fusion, we started the company over 20 years ago. The end in mind has been power plants. And so you need to, of course, demonstrate fusion and the science, but you need to do it in a way that will ultimately translate to power plants that can deliver energy that's economical, scalable, and deployable. And that's what we've done right from the beginning. So we take a very unique approach to the technology. We've had 20 years to de-risk it. And now the most exciting time for us is bringing all of that together in a large-scale demonstration that we commissioned just last year.
Take us through the business model right now, or business approach. Obviously, de-risking, there's a science involved, a lot of research, PhDs cranking away. Where are you now? Are you on the cusp of pilots? What's the product business model kind of thing going on now for you guys? Are you moving the needle? Give us the status of where you're at in the progress.
Yeah, so for us, the stage that we're at is demonstrating our unique approach to fusion at a commercially relevant scale. So we've done a lot of fusion. We've got 34 peer-reviewed papers and patents and all of those things. But demonstrating our unique approach, which allows us to move into commercialization at 50% power plant scale, is what we are on the cusp of doing right now with a machine that we just commissioned last year and have now started shooting these superheated gases called plasmas and compressing them. And our goal is to hit fusion conditions, which is really the early conditions are all about temperature. We need to see 10 million, 100 million degree temperatures inside of our machine, and we have a path to do that and demonstrate that over the next couple of years.
So are people knocking on your door right now in the data center area? Who are some of your early aligned go-to-market partners? Obviously, a lot of code designs involved because of science. The mechanisms probably have to get baked out and built out. What's the current relationship on that path? And what's some of the conversations about?
Yeah. So for us, while we're taking a unique approach, we have partners. And in the early days, we were partnering with national labs, academia, science partners, right? Help us to, validate, communicate, and move the technology forward on the science side of things. More recently, we started to have technology type partners that are helping us to develop and work our way through this technology roadmap. But then what comes next is our first customers. And so we started early on that and built ourselves a market development advisory committee of first movers all around the world that are, utilities, industrial heat users, et cetera, that we meet with on a regular basis to ensure that what we're doing is going to actually end up and so, yeah, we have a lot of conversations that have accelerated over the last couple of years, in particular with this, this up and to the right demand curve for energy.
On the product side, scope the. I'm trying to visualize what the product is. Is it like a huge substation? Is it like devices? Take us through how it works and how you see that being deployed as it rolls out in the future. What's it going to look like?
Yeah, so as you can imagine, creating the conditions similar to the sun inside a machine is a challenge. And to layer on top of that challenge, you need to be doing it in a way that's going to turn into a power plant. And so, those are harsh conditions inside there. High temperatures, neutrons that get created through the fusion process can actually damage machines. And so right from the beginning, we took an approach that would overcome those challenges of running a fusion power plant in those extreme conditions. And we built and designed an approach that basically it's kind of like a diesel engine. So you create this, superheated gas that's considered a plasma. Those are, a few million degrees temperatures in our case. And then what we do, much like a diesel engine, we inject that fuel into a vessel, we compress it, and it heats up more. And then we release the compression. So it's like a pulsed basis, much like a diesel engine. And those pulses create the densities and temperatures of fusion in our case and allow us to run the machine. What's a little different about what we're doing versus everybody else is the way that we contain this plasma, the way that we compress the plasma is using a liquid metal, just simple lithium. And having that liquid metal surrounding the plasma allows us to heat it up, capture the energy, protect the machine, and extract all the heat in a way that other approaches are going to be really challenged to do. So for us, we've got this sort of unique approach of taking existing materials, a lot of existing technologies. We're not using superconducting magnets or lasers to build a power plant using pistons, lithium, and really the beauty of fusion is that you can have a power plant virtually anywhere in the world that you could put a hospital. You think about the footprint of a hospital, you think about the safety of a hospital that's working in medical isotopes. That is the sort of same safety profile that you have in a general fusion power plant.
So the commercialization formats are really compatible. It's not like you got to quarantine off a big area. It's practical.
It's very practical, which allows for much more economical. It allows for dispatchable. It allows for a much more predictable path to power on the grid because the regulatory burden is completely different than that from fission.
I have to ask you because I'm curious because about 8 years ago when I started having conversation around quantum computing, very similar in scope, all these big machines and it's all custom and hard science. Now you're seeing that come to the market and people are using GPUs and other technology to make their entanglements and their quantum machines better, and there are also use cases specifically tied to these, so this similar pattern. Question for you is, are you using any technology simulations? How do you guys make the product? There must be some tech involved. Just share your thoughts on what goes in to making
Yeah.
that work, because you got the holy grail right there. If that can be commercialized, that'll solve a lot of problems, but I'm sure there's a lot of simulation, a lot of science. What's involved in the tooling,
Yeah.
making the product?
Yeah, so you're hitting on all the right things. We use a lot of simulation and AI in all of the work that we do. However, the difference in approach that we take is we also build machines and have built dozens of machines to prove out that these simulations, that these assumptions, underlying assumptions, whether that be on the physics side or engineering side, actually work, because we are pioneering a new, this is new. And so you can simulate things as a starting point, but you need to demonstrate them physically and do the practical fusion piece of it. Otherwise, you could be climbing the wrong mountain and getting wrong data from the simulation. So what we've done is we simulate, we run our demonstrations, we get peer reviews, and then that helps us to rebuild the simulation models that we've got and design the next machines with a much, much more accurate and realistic simulation rather than just theoretical.
I love looking at other founders and entrepreneurs like Jeff Bezos, Jensen Huang. They've done all the hard work and done revolutionary things. I have to ask you, I mean, it's always hard decisions. What's the hardest thing you've overcome? And two, Bezos talks about the one-way door, two-way door thing, where you don't want to walk through a one-way door and not get back. You want to have experiments. What were some of the learnings? What were the hard things you guys done or decisions? And what's a one-way door for you and a two-way door? How do you think about that as CEO? Because you have a lot going on. Again, false positive data, the right decisions. I mean, it's a lot's on the line.
Yeah. So Jeff Bezos is an investor of ours, and I've had the opportunity to share thoughts with him several times, and I'm a big fan. We also recently brought on an ex-employee of his, the ex-CEO of Blue Origin. Bob Smith is a strategic advisor of mine, and so been able to tap into some of those learnings. However, I myself, I've spent my entire career bringing new technologies from an idea in a founder's head to commercial success and scale up and exits, et cetera, and done that several times. And really, what I believe is truly important, especially in regards to fusion, is focus. And you need to have a very strong why, which that's easy to do with fusion. The opportunity is massive, both financially and just making the world a better place with clean, limitless energy. And sort of having that strong why and the focus and fortitude to continue to move forward on that, not get distracted with vanity metrics, side businesses, and these types of things. And so for us at Journal Fusion, we've been pure play from the beginning. We've avoided going down rabbit holes, side businesses, because the prize for fusion and commercializing fusion is so big, we've got to stay focused on it. It's a hard problem. So we've been really disciplined about that piece. I'd say the second thing also is you got to know when to stop working on things. And in an industry that's been often dominated by scientists, academia, national labs, which are very, very helpful and provide a baseline, and we work with a lot of them, you need to have the discipline to realize what's next and when to stop working on something. And once you've got the data from that simulation or that machine or that demonstration or that peer-reviewed paper. And so that's another thing that I think has allowed us to keep this incredible pace at General Fusion, is that discipline to stop working on things once you've got the information that you need. And this all puts us in a really great path to mid-2030s deployment of a first-of-a-kind plant. And that's going to be a very, very exciting time for us, but just humanity broadly.
I love the focus angle on that for sure. And it's hard, scientists get married to their ideas and projects to get their hands on it. You got to peel their hands off the projects. I'm sure it must be very difficult. The question I have for you, given the upside potential, obviously the prize is big, so yeah, check on the business front, but also the society benefit's huge. You mentioned that just now. What's the role of private-public partnerships in your journey? Can you share your relationship with, has there been money from governments? You mentioned labs earlier. How has that collaboration been for you guys?
So we're really lucky in this regard. We're a Canadian company, and we have partnerships all over the world. In the U.S., we partner with the U.S. Department of Energy. In the U.K., the U.S. Atomic Energy Authority is a deep technical partner, and we participate in different programs in each of those areas. But being in Canada is put us in a uniquely advantageous position of having a government very focused on us as a company. There's a global race happening in fusion. Countries all around the world racing for that big prize that you speak of, John. And we are Canada's horse in that race. And we've had the support of the Canadian federal government, mostly financially, but also engagement with the Canadian nuclear laboratories and other institutions in Canada that have given us a real advantage and leg up. And we're really grateful for the support that they've provided, but continue to reach out to global governments as well. And it's an exciting time and creates a lot of tailwind for us as a company.
Well, it's a decade plus journey for you guys. Awesome. I have to ask because I have my UN pin at home, and we've been covering clean tech for over a decade, and with sustainability, this is a huge discussion. Zero carbon. There's concern about radioactive waste, meltdown risk. These are like fear. I'm not saying that you guys have that, but how do you talk to that market? Because there's a huge mission. I think there's a shared mission around zero carbon on safety.
Mm-hmm. Yeah, safety has really plagued the fission industry in the past and caused things to go much slower than what was possible. The beauty of fusion is that you don't have those safety concerns, and not because of the way that we're protecting ourselves from fusion, but because of the physics of fusion. Fusion is not a chain reaction, and what happens when fusion fails is nothing. You just don't get fusion, and maybe to create those conditions for fusion to happen are so challenging that actually the flip side positive is that when you can't create them, nothing happens, and you're not working with uranium. There's no long-lived radioactive waste. There's no chance for a meltdown in fusion. The worst thing that can happen is virtually nothing. Yeah. So
it's safe. It's not. That's unbiased. That's not an issue. But you get to the zero carbon, you're around that mission. You check that box for sure.
Yeah. The what we create is energy and helium as a side product, and that's what ends up in kids' party balloons. So no challenge there.
Well, you got a lot of fun things going on around you, hard problems. It's brutally hard. Appreciate what you do. And again, energy is going to be the hottest topic. Water, cooling, energy, scarce resource, of course. You guys are on a very practical, engineering-led mission. Really appreciate the time and good luck. And we'll be following the journey, hopefully before 2030.
Excellent. This has been great. Really appreciate the time today.
Appreciate it, Greg. Thank you.
Bye-bye.
I'm John Furrier with theCUBE. We hear at the AI Factories, energy is #1, and the technologies will find a path. You're starting to see progress now. All the signals and signs are pointing to innovation around the demand and need for more energy. Stay here with theCUBE. We're doing our part to bring you the action. Thanks for watching.